Next topology is based on the OSPF. So in previous topology we had talked about one type of protocol is called as a routing information protocol. It's called RIP. Another one is called as a open shortest path first type of protocol. So first we will see the differences between these one. We have seen that the RIP is very simple to implement, but OSPF is very tough to implement, and hence there is some limitation in the case of this one. You can think about that it is based on the hop count and the maximum limitation of the hop count in the case of the 15. So for the larger type of the network, the RIP is not suitable, but for the larger network, you can say the OSPF protocol is mostly suitable. So this RIP and OSPF can be implemented on a router as well as the layer 3 switches. Okay. The very important thing is that the RIP supports the FLSM, which is called the fixed length subnet mask. We have seen in the previous example of RIP all the network having the subnet mask of /16 /16 etc. While in the case of this one, it will support the variable length subnet mask, which is called as a subnetted IP. So in possible that in one network there may be multiple users, in another network there may be limited user. Okay, so it is RIP is based on the distance vector, while it is called as a link state protocol, and it is based on UDP, is called user datagram protocol, while it is on the IP internet protocol. And internally the RIP run the algorithm is called as a Bellman-Ford algorithm, while this will run the algorithm is called as a Dijkstra algorithm. So we can say the RIP is very slow to converge, while it is in case of this open, this is very fast. OSPF is very fast to see the reflections. So these are the basic differences between the RIP and C. So now come to the point. Suppose if you want to implement the OSPF, is called open shortest path first. So the topology that we will implement, suppose we are having the three different routers and they are connected just like this. So we can think about that this PC0 is connected with a switch, normal switch, and this is again connected with the switch, and this is also connected with the switch. Okay, so you can think about that why we have used the switch here, because the switch, with this switch we can connect the multiple PCs here. So if I want to connect one more PC here, I can connect with the help of the switch. Okay, you can directly connect this PC with the routers also if you want. So for multiple connectivity or any type of the local area network, you can use this switch. So you can, it is very important that in the case of this, you can think about that if this is one router interface here and this is another router interface, so this will represent the network. So here the network will be different, so I am saying this is net 1, and obviously here the network 2 will be here. So any two interface of the router will be having the different networks. If it is connected with the serial link with the another routers, obviously it will be on the same network of this router. If I am saying this is R0 router, this is R1 router, and this is R2, so this is compulsory condition, this net 2 and net 2 between the two different routers should be same. And obviously if I consider here the net 3, so here another interface will be having network 4, so these two routers must be on same networks. So we can say R1 and R2 on the same network, so with this serial link, and obviously it is a net 5 will be there. So we can think about that there are multiple networks are there. Okay, each interface of the router will be representing the multiple network. So in OSPF, it's very important that you should divide the complete topology in area. Okay, so we can consider that this area here is a area 0, while this area is area 1 if consider, and this area is area 2. So if you want to implement this OSPF, suppose starting, if you had to, what the command that you have to give on the router. So suppose if it is representing the router interface, so initially you have to give the command is called enable. When you give this enable command, this will be run on this like this, and then when you configure here, just like configure terminal, so you will enter into the router configuration mode, and this will enter into the configuration mode. So it is called global configuration mode. And for example, if I am working on this router 0, So here for this you have to issue the command just like this, router OSPF, and then you have to give a command just like we can say is a process ID. So I am giving the process ID as a 1. Okay, so immediately we can think about that this will be run into the prompt of router OSPF conf. Immediately it will enter into this mode, and finally you can see here you have to issue a command just like network. You have to mention the network ID. So for example, whatever the network is there, you should mention the network ID, and after the network ID you should have to mention the wildcard. So what is a wildcard? Wildcard is just the inverse of your subnet mask, and then you have to mention the area. So whatever area that this router is covering, so this router is coming, so we can mention for this router as a area 1. So these 3 commands we have to run for OSPF configuration. So immediately we will switch to this topology, and we can see that for OSPF configuration we can see that this is working on just a minute, this is working on this IP, and this is working on this IP. So I will tell you, I will give you the demonstration. So for example, here we are having a network of 10.7, because you can think about that it is /16, while this is another network of 10.8 and it's another network of 10.9. So again the configuration will be same that we have done in the case of the RIP. I will show you the one of the PC's configuration. 10.7.0.3 is the IP address of this. The subnet mask is 16, so we have put 255.255.0.0. The reason I told you in the previous lecture that it is subnetted class A IP address, and the subnet mask of this one, the default gateway is the interface of this router. So we have put the IP address of this one as a 10.7.0.4. So for all these 3 PCs you have to give this type of the setting, and I will tell you what is the configuration for that one. So for configuration we can think about, here I put the first thing is that whenever you are selecting this 1941 router, this 1941 router doesn't have this serial link. Okay, so what you have to do, you have to turn off this router, and you have to add HWIC2T. So I will give the demonstration. You have to switch off the router, and after the switch off you have to just add this HWIC2T, and then again you have to on it. So you have to follow this procedure for all these 3 routers here. Router, because I am not connected, I just given the demonstration here. So you have to follow the same procedure here for all this router, otherwise this link will not be appear at all. Okay, so for example, just like I shown you what are the command that you have to give on there. So in the case of global configuration mode, you can enter by giving the command just like configure terminal, and after the configure terminal go to the command prompt and give the command just router OSPF and any process ID. So I will show you on this router. So here we have seen that in case of this it is necessary that you should give the IP address. So what type of the IP address that you should give? So this is a gigabyte 0/0 interface. So you go to the gigabyte 0/0 and give this IP address 10.7.0.4 and 255 as a subnet mask, and just on this port. Okay, and similarly you can think about that there is another interface is called serial 010. So serial 010, I have given the IP address of just like you can see 10.0.0.1 and the subnet mask of 16-bit, and then again I on it. Okay, so for this it is very important. You can see the topology once again. This whole topology is divided into the 3 different parts: area 0, area 1 and area 2. So you can think about that in case of this is covering this area and it is covering 2 different network. One network belongs to 10.7.0.0 and another network it is having the area 0 is having in the 10.10.0.1. So one network, this is another network, while in the case of this router it is handling three different network, one of 10.8.0.0, another in the case of this one is 10.10.0.0, while in the case of this it is handling another type of network is called 10.11.0. Before configuration, it is important that when we configure this router, so this router is in the area, so it is in the area 1, and it is handling only two networks, this network 10.10.0.0 and another network of 10.7.0.4, while this one is handling three different networks of three different areas. So for example, if I consider here this 10.10.0.0 is of area 1, while in the case of 10.11.0.0 is of area 2, while in the area 0 it is in the 10.8.0.3. So whenever you are coming, so this area ID you should mention here. So for example, we require here the wildcard. So wildcard can be given just like we are having the subnet mask of 255.255.0.0. So just you have to convert, just write down this string in the binary and convert all the zeros to the 1 and all the ones to 0. So for example, it is all 1, so it is all 0 after the conversion, and then all 1 after the conversion it will become 0, all zeros become all 1, so this will become 255, and then finally all zeros will. So we will use wildcard in the case of OSPF configuration. Okay, so the thing is that you have to mention the protocol here, just like you can see here there is no option is given for this configuration. So you can go to the command prompt and run this command just like this. I already given, so I will give the command router OSPF, and then I will give a process ID of 1. So this is my process ID. So I have to give the network. So one network is based on fast Ethernet 0. So this is 10.7.0.0, and wildcard for this one is 0.0.0.255.255, and it belongs to the area 1. So you have to give this command and press enter, automatically this will run. And for the another, if you give, because I already configured, so I don't want to disturb my configuration. So for the next command you have to give 10 dot something like here, and then you have to give the area again 1. Okay, just a minute. Area and this one, just this command become wrong. Again we will, so we will give here 10.10.0.0, and the command will be just wildcard will be 0.0.255.255, and the area you have to mention here as a 1. So for this configuration is okay, and then finally you just come to exit, and then you have to save this with the help of this. So I am not saving this because I already configured. For this I will show you the configuration that what configuration that we have did here in the case of this. So we have given enable, and if I run the what configuration that one, so you can think about that. I have given the IP address to 3 different interface. One interface is gigabyte Ethernet 0. So for this I issued a command IP address 10.8.0.4. so this is the IP address of this one, and then 255. I told you that you have to give the no shutdown, so no shutdown command you must issue here. Then next important thing is that there are 2 serial interface for this one. One is a serial 0/1/0. So for serial 0/1/0 I given the IP address of 10.10.0.2 like this here I given, and I given the subnet mask of it. And similarly for this interface serial 0 oblique 0 dot oblique 0, you have to give the IP address like this one. This thing you can do from here. If you are having the problem in the command line, you just give the IP address from here of to any interface. Okay, so it's not a big issue. Okay, so again I will come to CLI and then I will show you the configuration, that what configuration that I did for this. So in case of this, how I configured the OSPF. So OSPF I taken as I given the process ID instead of 2, I given the process ID as a 3. You can take 2 also, but any of the process ID should not be conflict with any of the router. It is necessary. So we can think about that how I configured. So you can think about that. This is the network ID of this network 10.8. which is connected here. So 10.8.0.0, and then I applied the wildcard for this network, and this it is belonging to area 0. It is belonging to area 0, while these two networks are belonging to, this one belong to area 1 and this one belong to area 2. So for this we have issued the command for this. Similarly, the similar thing that you can do for this router. So again we will check the by this command you can check what is the configuration is there. So for example, you can see here what configuration of the OSPF we have did. Okay, so you can see the OSPF configuration. So just a minute. So in this case you can think I given the process ID on the command line as a 2, and then I given the network of this interface as well as second command of this interface. So one command is for network 10.9.0.0 and 0.0.255 area 2. Okay, and another network of area 2, the next command I issued for this. So after the configuration, and if you give the some time, so this one is near about 30 to 40 seconds after the configuration, if you check that whether the packet is going from here to here or not. So your packet is going and this packet is going, it is showing successful. So from here 10.7, by using this OSPF protocol, I can just check that if I am sending the packet to this, and it is also successful. So if you run the simulation, you can see the topology is working like this, because we have considered the source and destination network like this. So ultimately the packet is routing with the help of this OSPF protocol, and then finally they are traveling on the network. So you can check. The packet is moving from here to here, and finally they are delivering without discarding or without failing the packet. Okay, so it's also very tough protocol, but in our network, in any network nowadays, OSPF works very smoothly. You can see the packet is delivered finally. Okay, so you can just you can test this topology on your PC and comment.